Thank you everybody for being here on a Wednesday afternoon, last session, almost last talk. Appreciate you being here. So I'm going to talk a little bit about Hyobanche. I've been working on Hyobanche since 1996, my first trip to South Africa. And I actually got interested in the genus mostly because of the interesting molecular evolution of what happens to a holoparasitic plant as it loses its ability to feed itself. And so that was really my introduction into the genus, was doing a survey of plastogenes in parasitic plants from autotrophic to hemiparasitic to holoparasitic. It turns out that Hyobanche, which occurs only in southern Africa, had never really been worked on. And so I just kind of got interested in it. And so the opportunity came up to work on a field trip to South Africa shortly after the end of apartheid, and I've been working on it ever since. So when I first started working on Hyobanche, there was a very small genus. It still is a very small genus. The first species was described by Linnaeus in 1771. And then it took more than 100 years for any other species to be described. So shortly after Bolus tackled Atropicuria, there were a suite of species described. And then it was another 100 years nearly before I described the next one. So it's been just a little bit of a taxonomic puzzle. So when I started this study, Hyobanche sanguinea was described to be kind of the most broadly distributed. And it turns out that anything that has a morphology similar to the flower shape of sanguinea, which is curved and hairy and pretty nondescript on a herbarium specimen, was just called sanguinea. And then the next broadly distributed one would have been Hyobanche rubra, followed by glabrata. And then the rest of the genus was really kind of narrowly distributed in small areas along the coastline. And so just to give you an introduction to what those morphologies look like, this is not what they look like in herbarium specimens. Herbarium specimens are black, and everything's glued together, and you don't have any characters, and you really don't know what you're looking at. I mean, basically, it's a blob. And so, I started to learn the genus as I got out in the field and started to explore it. So basically, Hyobanche and sanguinea and Barclayi kind of have that general morphology. Hyobanche rubra, glabrata, and what was called the calvescens, but there was no herbarium material for it, basically had that kind of morphology with a straight corolla tube. And then along the KwaZulu-Natal coastline is Hyobanche fulleri. Basically, most of the herbarium specimens are only from the early inflorescence, so it kind of looks like the Hyobanche sanguinea, but if you get out in the field, you see that it has this very elongate inflorescence. The most distinctive species at the time I started working on this was Hyobanche atropicuria. It's an interesting species. It only occurs in the Western Cape. It has almost a purplish black corolla, and it's the only species that actually has a scent. And it turns out that it's pollinated by elephant shrews. And there's a couple of videos online that I recommend you just do a search for Hyobanche atropicuria elephant shrew, and you'll see the cutest videos of elephant shrews sticking their long snouts into this flower. Petra Westra from Germany did that work. And then the other very distinctive species is Hyobanche robusta, which truly lives up to its name. It's got an inflorescence about this big, a rhizome about this big around, and the rhizome can extend underground for about 3 meters. So it's a robust species. So that's what I had to work from. And then after I started shuffling through herbarium material, I realized that there's quite a bit of diversity in Hyobanche sanguinea, more than I think was recognized at the time. And so I started to go to locations where some of these weird morphotypes were found. And it turns out that they're very distinctive in the field. So I really got intrigued by this, and so I started a morphological study of the genus. And so this gave me the opportunity to go to all the different habitats of Hyobanche. Most of the species of Hyobanche occur along the coastline of South Africa. It's a very long coastline that extends from KwaZulu-Natal all the way down to the southern tip of Africa, all the way back up to Namibia. So that's thousands of miles of coastline. Darn. I get paid to go play in places like that. It's beautiful. A lot of the vegetation is strand-felt, some sand dune systems, a lot of rocky coastlines, but it's an extremely beautiful place to be. Several species occur in desert habitats. The Karoo is a typical succulent desert. There's several different types of Karoo vegetation across South Africa, and there's a lot of mountain ranges in southern Africa. And before I learned a little bit of Afrikaans, I always thought this meant that if you come onto my property, I'll shoot you. It actually just means no trespassing, but it looks like you're going to get shot. A couple species occur also in the highlands. The Drakensberg is the highest area in southern Africa, and then the highlands of Lesotho. So my goals for this study was really to try to understand the species diversity and to limit species and try to understand what was going on morphologically and molecularly in this genus. The problem I had in trying to do species delimitation is that, you know, although Linnaeus described Hyobanche sanguinea in 1771, there was never a specimen designated as the type. And so if you think that there's diversity within the genus or the species Hyobanche sanguinea and you want to separate species from that, you actually have to have a type specimen. So it's really difficult to figure out what is a type. And so my first challenge was to kind of solve that taxonomic puzzle. And then I did morphometrics to try to assess the character differences objectively. And the problem with this parasitic plant genus is that the only parts that you really can look at are above ground. It's the inflorescence. It's a holoparasite. There's no stem, there's no leaves, there's really very difficult to tell what's going on from those black blobs that are glued to a herbarium specimen. And even if you can dissect a flower off without destructively sampling the specimen, it's kind of a challenge. So that was one of my goals, is to find those characters that could distinguish among different species. And then the final goal was to try to figure out how many species of Hyobanche really are there. So I'm going to talk mostly about the Hyobanche sanguinea complex, but also mention what I found otherwise. And so to tackle the taxonomy and try to figure out what the type specimen for Hyobanche sanguinea was or is, I actually had to go online and look at all the digitized specimens for the Linnaean collections. And there's two collections. There's one in Sweden and there's one in London. And there were about 8 specimens digitized, and only one of them had a name of Hyobanche sanguinea. And so that should have been the type, right? But there's no information regarding where or when it was collected. So to kind of do some detective work, I had to actually research the history of botany in South Africa, which was a lot of fun for me personally. After looking at these specimens very carefully, I did come up with about 35 characters that I could use to try to tease apart some of the species diversity. And so I looked at specimens from herbaria from southern Africa. Actually, I was able to measure 247 of the about 400 and some odd species or specimens that I have borrowed. And so I was on sabbatical last fall, so one of the things that you do when you're on sabbatical is to finish projects, so I actually got to do the morphometrics, but in order to analyze it, I had to actually learn R. Now, I'm an old dog, and this is a new technique, and all my students know how to do all that programming and everything, but I decided that I was going to learn how to do R, and I'm here to tell you, you can do it. If I can do it, you can do it. It's not that hard. So actually, I was able to use several different packages, and I used a Gower general similarity coefficient, which allows you to use quantitative and qualitative data at the same time, and then to pull together a name joining tree. So this taxonomic puzzle, I actually published the results of my designation of the type specimen earlier this year in Phytotax, so that's an open access paper. I only bring that to your attention because I really enjoyed the little bit of detective work I did, and I got to quote several different historical references, which are kind of fun. So I just bring that to your attention. But the prologue for Hyobanche sanguinea is really the only description we have of the whole species, or that this is what Linnaeus said. He said, habitat ad cap Spee. Okay, so that's the Cape of Good Hope. Well, okay, so that should be the type locality. That would be on the Cape Peninsula of South Africa. This is the only specimen in the collection that actually is called Hyobanche sanguinea. And this was annotated by von Linné. And it was collected by Anders Sparman, and that's the information. That's all there is. There's no date, there's no locality. This, having no date, makes it so that you have to go and actually do a little bit of detective work. And so it happens to be the case that Anders Sparman did a travel log. And so he traveled from 1772 to 1776. He wrote a book called A Voyage to the Cape of Good Hope, towards the Antarctic polar circle, around the world, but chiefly into the country of the Hottentots and Caffres from the year 1772 to 1776. So when you read this little autobiographical account of his travels, he lived on the Cape Peninsula, actually on the side where Simonstown is on False Bay, starting in 1772. Well, he was only there for a few months before he actually latched onto a cook voyage and actually left, and then came back and did his exploration into the land of the Hottentots and Caffres. So he refers in this book, in fact on page 35, to seeing Hyobanche sanguinea in bloom in late winter or early spring in 1772. Linnaeus described sanguinea, released that description in 1771, so the earliest collection of Hyobanche sanguinea had to be 1772. And so I actually took this information and assigned a lectotype to that Linnaean specimen. Okay, so here is a current collection, or a more current collection, of the Cape of Good Hope on the Cape Peninsula of Hyobanche sanguinea. This was actually in Cape Point, just not too far from the actual tip. So this is kind of what I consider the ideal, and that's the dissected specimen. So I did this morphometrics, and it turns out that there are several groups of morphologically similar specimens that form clusters. The color coding is significant to me, I won't describe it, but there are regional patterns that emerge from that Hyobanche sanguinea complex. That's somewhat reassuring that maybe there are some real signals here in terms of the morphology. So if I look at the whole genus, of all those specimens that I measured, there were two major clusters in the neighbor joining tree, and very distinctive morphologically as well. So the first cluster, this part up here, I'm going to call section sanguinea. This has a velate corolla, very hairy, and it has glandular hairs inside the corolla tube. This group here is what I'm going to call section rubra. All of the sections in this group have a straight corolla, no glandular hairs within, and a ring of long multicellular hairs at the base of the stamen attachment. Fairly distinctive characters. So if I were to just label these, here's Hyobanche sanguinea. It turns out to be a distributed plant. It's only around the Cape Peninsula and surrounding areas. Atropurga is distinctive. Hyobanche fulleri, instead of being restricted to KwaZulu-Natal, actually goes from KwaZulu-Natal all the way down almost to the Cape of Agulhas. And Berkeley, instead of just being in Namaqualand, extends from almost the Cape Peninsula all the way up to Namibia. Hyobanche rubra is all this area in red. I had to subsume Labreda and Halvescens into that one species. This is Hyobanche robusta, and this is the new species I described, Tenaphila. So then I have the new species, these distinct clusters. I will give them names, these 5 names here, Hanacomii, Carensis, etc. And so here's what the genus looks like. Here's section rubra, Hyobanche rubra, Hyobanche robusta, Hyobanche tenaphila, very well supported in that tree. Section sanguinea, these are the original species, Hyobanche sanguinea, Atropurga, fulleri, and Barclayi, and then these are the new species that I'm describing. So that's it, that's solving a taxonomic puzzle.
Thank you. Questions?
Who's the Laidler family?
What's that?
The Laidler family.
The Laidler family. Hyobanche laidleri is this little species here. The Laidlers are my best friends in the entire world. Okay. Dennis Laidler worked for the government. He was a naturalist, did a lot of environmental impact statements, retired, and now it has a guiding company. Best mountaineers you'll ever meet, best people you'll ever go in the field. I've spent months of my life camping out in the bush with the Laidlers, either their sons or them. They're wonderful people. And this plant, Pesman, or Hyobanche laidleri, is near and dear to my heart because we actually were on our belly together and I said, this is a new species. I know it is. So that's named after them.
All right.